All right, so we're analyzing a series of related equations with their delta H values to figure out the enthalpy change for a balanced equation with fractional coefficients. So we have in our context box here the equations that we're going to use to get our overall reaction down here and then figure out its delta H value. So if I start by looking at reaction 1 and I identify what's in reaction 1 that's also in my overall reaction, I can see that it's water. Now water is a product here, but in my overall reaction I'm looking for, it's a reactant. The other thing I noticed is that the coefficient is 2 here, but the coefficient is 1 here. So I'm going to need to make two changes. I'm going to need to reverse this reaction, and I'm going to need to divide it by 2. So I'm going to rewrite this reaction with those changes made. So I've divided all the coefficients by 2, giving us H2O liquid goes to H2 gas plus 1/2 O2 gas. And I changed the delta H value by dividing it by 2, as well as changing the sign because I reversed the reaction. For equation 2, if I take a look at what's there and what's in my overall reaction, I can see that it's the SO3. Again, I want SO3 to be a reactant in my overall reaction, not a product, so I'm going to need to reverse this reaction. In addition, there are 8 moles of SO3 in reaction 2, but in my overall reaction there is only 1, so that means I'm going to need to divide all of the coefficients and the value of delta H by 8. So I'll rewrite this reaction with those changes made. So the reaction has been reversed, so the sign of delta H has changed and everything has been divided by 8. So that means the coefficient of SO3 is 1. For sulfur, since the coefficient was 1, the coefficient becomes 1 over 8. And for oxygen, the coefficient was 12, so it would be 12 over 8, but I reduced that to 3 over 2, so that we had the same denominator as my other molecule of oxygen. Now we'll take a look at reaction 3. In reaction 3, I can see that H2SO4 liquid is a product, which also is in the reaction that I'm looking for overall, but I have the wrong number of moles, so I'm going to divide all of the coefficients and the value of delta H for this reaction by 8. So now we made those changes, so I divided all the coefficients by 8. So for hydrogen, the coefficient was 8 and becomes 1. For sulfur, just like in the second reaction, the coefficient was 1, becomes 1 over 8. The coefficient for oxygen was 2, or was 16, so it becomes 2. And my H2SO4 liquid now has a coefficient of 1, and I've divided the value of delta H by 8. Now we're going to check and make sure that all of these changes give us the overall reaction that's shown above. So if I take a look, I'm going to check for things that show up on the product side and on the reactant side and see if I can cancel them out before I write what I have overall. So for example, I'm going to take a look at water first. I have 1 mole of liquid water here, and there's no water anywhere else. So that's coming down into my overall reaction. If I take a look at hydrogen, it's not in the overall reaction I'm looking for, so hopefully it will cancel out. It shows up here and here. So there's 1 mole of it on the reactant side, 1 mole of it on the product side. So we're not going to include it in the overall reaction. The next thing I can do is take a look at oxygen. Oxygen is not my overall reaction, and I find it in a few places. I have a 1/2 mole of oxygen as a product here. I have 3 over 2 moles of oxygen as a product here. And then I have 2 moles of oxygen as a reactant there. A 1/2 plus 3/2 makes 2. So I have 2 moles of reactant, and together these make 2 moles of product. So they're going to get canceled out as well. I'm not going to write them in the overall reaction. If I take a look at SO3, SO3 only shows up in reaction 2 as a reactant. So it's going to be part of my overall reaction. The next substance I should take a look at is sulfur. I have in reaction 2, 1/8 of a mole as a product, and in reaction 3, 1/8 of a mole as a reactant. That's good. I can cross them out, and the only thing that is left is on the product side, H2SO4 liquid. So I've successfully manipulated those reactions to give me the overall reaction I wanted. So I can take the 3 delta H values and add them up to get the delta H value for my overall reaction. And when I add these together, I get negative 87.2 kilojoules. If I look back at my numerical response instructions, it says to give me a 3-digit answer, and the negative is already there, so I would fill in 87.2 as my numeric response answer.